with closing comments, and we're going to do this under the Lynn Vendine lecture with our international fellow Beniot Bardy from the University of Montpellier. So Benoit is just going to give us some comments and remarks on his thinking from the last couple of days.
Thank you, Carl. Well, I'm not sure I need to thank you, actually, because you gave me something absolutely impossible to do, and I'm going to be delighted to do it. Thank you for bringing me here. I have a bad news and a good news. The bad news is I'm not going to be able to summarize and comment on like everything I've heard these last days, which is impossible. The field is so diverse and rich that this enterprise is not possible. The good news is I have only 25 minutes to do it and not like 60 because there is a little mistake in the program. So 25 minutes, just a few comments on what I heard. I have remained very silent these last days. I mean, I was, I had many questions myself to ask to the speakers, and I say, you're not going to ask any questions because you're going to have 25 minutes for yourself just to ask questions. I'm going to ask more questions than I'm going to give answers. But that's the way I have experienced these 3 days in this meeting. So what I will try to do is very quickly summarize, categorize, clusterize some of the ideas that I've heard. And of course, as soon as you start categorizing like items and people, you make more enemies than friends. And but that's the way it is. I'm used to it. More importantly, I'm gonna try to push the field a little bit forward with 4 questions. And I got this inspiration from your talks, these 16 talks that I heard these last days. So there are 4 directions that I would like to propose, or that I would like to just, show you that together as a community, the group of kinesiology that we are, we can target these questions, we can answer them, and that the only group that can answer this question is this group. And because I think the field of kinesiology is so diverse, so multidisciplinary, so complementary, I think we have the unique expertise to answer some of these questions. So I have like 20 minutes to do that. It's going to go very fast. And I'm going to inject one of my study in this talk just as an illustration of ways to answer at least one of the questions that I'm going to ask. Okay, so this is a sort of loose, weak categorization of the 16 talks that I've heard. The science of movement, forms, functions, and skill that Carl put in the program, basically this is not the different session. It's a slightly different organization that I have. So I've done that every day, just putting things together. And so across the lifespan was an important contribution, right? From minus 200,000 years to plus 70, 80, 90. I'm going to suggest that we can go much more than that. Coordination and control, and this is not surprising, was kind of the hardcore set of questions that we ask. I think it's connected to the topics and the title that Carl decided for this meeting. Of course, the question of the control by the central nervous system and the way it communicates with muscles and behavior was a concern for some of these talks. And we talked a lot also, mostly today, but also the first day and in a few of the talks, on the context dependency, on the things that we're looking at. We tackled the culture aspect, and I'm going to go back to that at the end of my talk. I think it's an absolutely crucial point that we need to, together, start to reinvestigate and follow Blandine much more than we have done in the past, let's say, decades. Because she was really one of the primary scientists trying to look at movement in the context of culture, and I think we should do more of that. So this is not very interesting. What is more interesting is like the kind of questions and the thing that we have done this last day. So the challenging questions that I've heard, mostly turn around models of coordination and control. And I forgot to say, of course, that these categories, they are not exhaustive and they are not mutually exclusive, right? So, there are lots of communication in between. And when Bev, for instance, were looking at infants neurophysiology, of course, what's behind is the neural control of infant movement. So it's very hard to categorize the way I've done it, the different talks. But so models of coordination and control was probably the attractor, like the key component of this meeting, and it was very interesting and to see the different ontologies. And when I say different, sometimes diverging ontologies that we're using to capture these phenomena and the way we model them. 30 or 40 years after the first model action controversy that started in the US and in Europe, we are still there, right? So we're still there talking, agreeing, and sometimes disagreeing. And we had a few examples today, about computational versus self-organized way to capture the way we move and to understand coordination and control. Clock-like versus emergent timing. Probably the main discovery for me this week was the agreement, between Howard and Mark about emergent timing. I mean, this is a milestone in the history of timing. So that was interesting to note. There are ontological positions that are not reconcilable. Perception cannot be direct and indirect at the same time. A central integrator that was mentioned this morning versus a direct perception of information specified across energies. We have things here that are not reconcilable in many ways. Maybe there will be in 20 years. They are not today. We need to agree about that disagreement. It still exists. And this is who we are, right? So we have moved in our lives, in our scientific life, in different ways. We have found a common way to understand the model control and the coordination problem. There remain issues that are sources of discussion, dispute, and disagreement. And this is the way it is. It moves the field in different ways, and this is not going to change in the next day or years. Until the point where integration of these different disciplines is going to arrive, and we have already signs. I'm going to go onto some of them today that it's happening. Different levels of analysis. This is kind of a standard, not from genes. I've not heard anything from genetics to like muscles and behavior and population, but genetics is entering the field, progressively. And the way, so we're all dreaming about this integrated model of behavior, going from genetics to population and behavior, like this big differential equation where we have like the small time scale and the large time scale, the individual and the population, that can explain, behavior starting from gene and going to cognition. This is not yet where we are, but we're moving forward to that, and there are models, and we've seen a few of them. That can help us going into this direction. Different types of movement form and skills. Not a lot of them, like 3 days, 16 talks. And we've been talking about standing and walking and running and reaching and tapping and drawing and cooking, baking, contracting. This was Jen in the mostly isometric contraction, which is a kind of movement. And no movement is a singularity in the movement space that we need to take into account. Pressing, stone napping, and a few other cultural movements. But not like in 3 days of talk, not like hundreds of skills, right? So we're sort of looking all together most of the time at the same type of skills. And I think when we put that in the cultural context, this is something that has to change, right? Because we cannot have a theory of movement, based on like 5 or 6 different skills. I mean, we can, but we can't. And we have to, find ways here to enlarge a little bit what we do. Different population and context. I'm going to go back to that in a minute. So based on this, I'm tempting here, and this is probably not for NAK 2018 in Chicago, this is probably for 28 or maybe 38. I just want to put like 4 items in this slide. and illustrate what I think this group together can do to answer some of these burning questions that are out there and that probably will develop in the next years. Well, the number one is not on this map. The number one is that we're going to keep doing what we do. So forget about what's going to come next. You're going to keep doing what you do. Mark is going to keep searching new definitions of life. John has switched from the control of standing, the control of balance during standing, to the control of balance during walking. Howard has been doing some timing. Bev is doing. We're not going to change what we do, right? What we do are the burning questions. We do not want to change that. But at the same time, there are ways maybe to look around and enlarge a little bit what we do, and I will propose a few ideas. So in terms of coordination and control, I was absolutely astonished by these different presentations that we had, mostly by Daniel, but also by John and Jen, right before me, about the possible ways that we have to look at fundamental properties of movement, way back in the history until 70 years old, 80 years old, 90 years old, centenarians, who I think are taking over the planet very soon. What kind of data do we have in this population? So let's expand a little bit our boundaries and ask ourselves a question like this one. So I know this is a little bit silly, but I'm putting this on the side anyway. So these fundamental biological laws that we have discovered in the since, let's say, motor control, since Woodworth, basically 100 years ago, 120, 30 years ago, the bell-shaped velocity profile when we're reaching for an object. Right? This asymmetry between the acceleration profile and the deceleration profile, the change in variability during the movement, the final control, the perfectly guided movement at the end. So did that exist 200,000 years ago? Probably yes, would say Mark. Probably no, would say others. So what kind of evidence do we have that these fundamental laws of movement were there a long time ago and are still there with the centenarians? What is the dynamics of this? So how these laws have been taken into account, over the course of a long period of time? So the one-third power law is an example. The fractal properties, the 1/f, the long-term correlation during gait that Richard was mentioning yesterday. Did that exist before? Does it still exist when we are 90, 100, 110 years old? All these questions, from very early in time until when we're getting very old, what kind of information do we have about how these laws are taken into account? I was amazed by Bev's presentation about the neurophysiology, during infancy. How precocious can we go? Can we go intra-utero? Can we go -1? Can we go -2? Can we use the technology, that Bev has presented to, look at coordination and basic motor control very early? Do we do that today? So I think this is the type of question that, thanks to both the technology and the expertise in this group, that we can possibly target. Just an idea. Another one was prompted to me by John, and it's about this relation that exists and most of the time does not exist, with very few exceptions still today, between our community and the community of artificial movement, robotics, VR, not as a tool, to understand or to manipulate the kind of thing that we want to manipulate, but as a community. Mostly DARPA in North America, the ICT robotics in Europe, which is probably the highest, the most funded program in robotics in the world. It's about 100,000 million euros per year given to people doing movement science in human and robots, and it's absolutely blooming in Asia. As John was mentioning yesterday or the day before, robots are changing, and they are changing to the point. So human-like robotics is becoming not only trendy, but this community is inventing solutions that we have on our side not yet thought about. So they used to be inspired by the kind of things that we do, exploiting, passive dynamics as an example, compliant robotics as another example. So they've been like mimicking or exploiting what we know from human work to a point where today the community has this sort of bilateral exchange. And so now we, looking at human locomotion, get some inspiration from what these people are doing in robotics. And this community, in most situations, ignore each other. I don't know, there are a few, of course. There are a few consortia that are teaming up together, trying to understand these questions, but there are not many of them. And, as John mentioned, going to robotic conferences, doing joint projects together. I don't know if NSF, or NIH fund this sort of joint, collaboration. This exists in Europe. That's the thing that we have to consider. But not only for this reason, is that like some of the main concepts that we have developed in our field, the perception of affordances, for instance, is one of these examples, is very active in robotics. These are a few pictures from the World Robot Conference that was in Beijing just 3 weeks ago. Brain-body computing interfaces are taking over in Asia in a way that is unprecedented. And there are solutions in terms of, there are solutions to some of the problems that we're raising that exist in this camp and that we need to pay probably more attention to. But not only for this reason, robots are there. Robots are there. And if we think in terms of our children and the next generation, they're going to be interacting with the technology. And it's not only understanding the way we move, it's also understanding the way we move in a technological environment with these little creatures that are going to be absolutely everywhere. And the way these machines are being used to treat pathologies, social disorders, contribute to education, is something that where they get tired from time to time. So they need to recharge. If you look at this type of interaction, we're going to see that more and more often. And so being in that relation, with this community is something that I think is still missing in our field too much, and probably something that we can work on. The third aspect, I'm going to spend a little bit more time on that. I don't know how much time do we have. We have like 10, 15 more minutes? Probably. The embodiment notion. And we heard this concept a few times this week. Daniela was one of the times that I heard embodiment, and I think, I forgot, but I think like 2 or 3 other times. This embodiment notion, which basically describe in different terms this idea that our perception action capabilities, our sensory motricity cannot be looked at and studied independently of the higher executive functions. I'm going to skip this one. There are a wide variety of theories today that is taken and accepted this notion of embodiment in situation, of course inspired, I think, by Gibson in many ways, but also, from the field of psychophysics. You're familiar with Francesco Varela and the notion of inaction that was sort of operationalized by Kevin Oregan and Alvanoy, this concept of sensory motor contingencies, the work by Dennis Profit here actually, embodied cognition, embodied music cognition, psychiatry. I'm going to give one example from my work on psychiatry. All these ideas that basically we cannot consider like body and mind being separated. We cannot look at the way we move. We cannot look at higher level executive functions, perception, cognition, memory, speech production, and many other things, without taking into account the body and the sciences, the various sciences that are looking at the body. And so the way we move tell us a lot about who we are. You're going to see that on the dance floor tonight, especially with the current presidents. So pay really attention to the way they dance. And you're going to find some interesting information about who they really are. And I would like to give you like one example of the way I'm doing it in my own research. It's a quick, like, a quick presentation of a very simple thing, which is like, you're doing this movement. Just this very simple lateral movement. If you are doing that, you're going to do that in you have your blueprint. You have your very specific way of doing this movement. And I'm going to show you a very simple method. It's not that simple, but it's not very complicated to capture that signature and then use that signature in a different context, including a cultural context. This is mostly related to the mental health issues that we're dealing. So you're doing this movement, you take this position signal, you get the velocity, you normalize the velocity, and you have this distribution of the velocity profile. So the probability density function of the velocity. That's something easy to get. Then, so you do this movement, you do another movement, and then you have another probability, and you can compute a matrix which is called the Earth mover's distance, which is an index of similarity between like two movements that you're doing. So here you have two movements that are very similar. You do the Earth mover's distance, which is, this is not very important. It's just the cumulative distribution function, of the two velocity distribution, and you end up with a number. And this number says, when this number is close to 0, then it means that the two things are very similar, and when this number is close to 1, it means that the two distributions are very different. Like if they were done by two different people, right? So it's an index of similarity between this type of movement. And if you're doing this movement now, you're going to be somewhere along this continuum. So 0 means similar and different means 1. So we have reduced here the notion of similarity like to one number, expressing things that are similar and things that are different. And you're somewhere on that continuum when you do this movement 20 or 30 times. Now, when you've done that, you can plot that into a similarity space. These dimensions are not very important. It's just techniques that we're using to plot space like this. And so each dot is one value of this EMD, this central tendency of similarity. And the ellipse basically captures like one individual. So let's say you're one individual in that space. And so there are 20 or 25 individuals here. Now, if you do this type of movement, like just looking at someone else, you're not doing anything, I'm just looking at you. You're not doing anything yet, I'm just looking at you. Then I'm going to be on that space on the right. And as you can see, some of us will stay where we were when we did that in this solo condition, and some of us move to another part of that space. And now, if we're doing the same thing, like so we're improvising, or I follow you, or you follow me, so solo, duo, different types of condition, we can look at where we are in that space. And so we can look at how we change, we can look at the dynamics of where we are in that space, and so how it changes over time and over different conditions. And so there are ways here to evaluate, through this notion of similarity, situations that are very, very different situations. We can evaluate the role, of the social roles, whether we're leader, whether we're followers. We can evaluate motivation. This is something that we discussed with Maureen a little bit. You can evaluate, mental health and evaluate those of patients that suffer from social disorders. This is a thing that we do in this series of study. And so that's an example of a matrix inspired by some theories that we're having, trying to bridge the gap between the fundamental principles in motor control and things that comes from pathologies, humanities, social sciences, psychology. So maybe there are ways to bridge the gap between our different sub-part of the community here to address some of these questions. And and the reason we're doing that is because then you can feed a little machine, this is robot here, with that number, and have this little I-cube robot produce movements that are similar or different from the movement of a human. And the reason we're doing that is because those patients who suffer from social disorders, schizophrenic patients, autistic children, social phobia patients, they all share, this deficit in social disorders, and similarity is a way to trigger social interaction, because doing movements that are similar or interacting with someone who is similar to me, like my avatar, is a way to trigger social interaction, and then you can use that to progressively have them interact with people who are different. So from similarity to difference is the kind of thing that we're looking at, and this is why we developed this matrix. And the final one that I want to quickly target here is this context laboratory versus real-world studies that we have discussed many times this week. And I think we need to pay more attention to that. And of course, we need the lab, right? We need the lab. I'm an experimentalist. I do research in the lab every day, and I'm not going to stop doing it. And it's, of course, it's reductionist. Of course, there are things that we're losing. We need the control. Of course, we do that. But we have to realize, what we have said already. I'm just hammering again on that idea. Walking on the treadmill is not the same thing as like walking, as Blondin showed and others, outside in your village. It's different. It's different. And it's not only the context sensitivity, it's different. Because of the obstacle that you're avoiding that you have or that you don't have, because of the slippery of the ground that you have that you don't have, because of the optic flow that you have when you're walking outside that you don't have when you're walking on the treadmill. Which change completely, the way you're controlling your stance and your balance and your locomotion in some ways, not in all ways, but in some ways. So what I want to finish with today is that we have ways, a group like this one, we have ways to sort of balance the type of research that we've been doing for pretty much 50 years or more with more natural studies without preempting or distorting too much the question that we're asking, thanks to the technology. So wearable technology allows us today to capture whatever we want outside. Walking, running, navigating. So just a good GPS and a little inertial sensor that you put on your shoes or on your belt is sufficient, not for everything, but it's sufficient to capture lots of things that we're studying. And doing more of this natural research with this little technology and balancing the type of experiment that we're doing with more naturalistic studies is something that we need to do more. And why we should do that more? Because it was obvious in Blondin's presentation, right, and others. Bimanual coordination. We're studying bimanual coordination. Well, bimanual coordination, when you're outside, when you're in your real life, is an emergent thing out of so many interacting properties and parameters and constraints that its dynamics, its value, its parameters, its changes, are different from the things that we're studying in the lab. And today, with the technology, we have ways to explore these ideas, and some of us are doing it. Bill Warren, that was mentioned before in Providence today, is doing large-scale navigation situation with like 30 to 40 people working outside. And the thing that Bill discovers is not what was found in the lab for the last 10 or 15 years. So there are interesting avenues here for, I think, research. And I think a community like this one has a unique capacity together to tackle some of these issues. And for instance, I want to show you, I'm not going to show you, I just wanted to, I'm going to show you this one. This is the thing that we're doing, and this is the thing that we should not do anymore. So we're doing group synchronization, and I want to see how this, transfer to that. So this was given to me by Julie Strand. She's an incredible, talented ethnomusicologist. She was at NEU for some years. She spent 2 years in Burkina, just living with these people. So we have all components here that the thing we're studying. So the skill that we have discussed, like the partial coordination, like the proximal distal organization, like the bimanual coordination, the interpersonal and social coordination, like the coordination with the music, this sort of rhythmic situation that is known to untrain movement, the social aspect. So you have very interesting things happening here in terms of entrainment between people in the music. Lots of biomechanical things to study. So I'm going to end here. I think a group like us, has the skill and probably more time now to study this kind of natural behavior. And voila. Thank you.